Hello friends, welcome back to the class of Thermodynamics. In today's session, we will look after the problems which are based on the first law of thermodynamics. Okay. Now, in our previous session, we have seen what is the heat transfer and work transfer in the case of different processes: polytropic process, adiabatic process, isothermal process, isochoric process, and so on. Okay. Now, after that, we have seen one numerical, a sample numerical based on the first law of thermodynamics. In today's session, we will see some more examples or more numericals which are based on the first law of thermodynamics. Let us proceed. See the first problem. It is written 1.5 kg of liquid having constant specific heat of 2.5 kJ per kg Kelvin is stirred in a well-insulated chamber, causing temperature to rise by 15 degrees Celsius. We are given a liquid whose mass is how much? 1.5 kg. Note down, mass is given 1.5 kg. Second thing which is given is specific heat. How much? 2.5 kilojoule per kg Kelvin. The specific heat is given. Now it is perfectly insulated. It is perfectly insulated. Okay. Now there is rise in temperature by 15 degrees Celsius. Rise in temperature means change in temperature. How much? 15 degrees Celsius. Rise means increasing. So delta T is positive 15 degrees Celsius. You have to find delta E and work. W is nothing but work for this kind of process. You are given mass, specific heat, and change in temperature. You have to find delta E and W. Now if you will remember what is the formula for delta E. Now delta E is nothing but you can say the summation of kinetic energy, potential energy and delta U. But here kinetic energy and potential energy is not considered. There is no information by which we can calculate kinetic energy and potential energy. So we are neglecting it. So now the thing which is remaining is only delta U means internal energy, change in internal energy. So delta E is equals to delta U, which is change in internal energy. And what is the formula for calculate the change in internal energy? mCv delta T. mCv delta T. Okay. See, same thing here. mCv delta T. Now m is mass, Cv is specific heat, and delta T is change in temperature. How much mass? In question it is given 1.5 kg. So put m equals to 1.5. What is the value of Cv? See, it is given constant specific heat. How much? 2.5 kilojoule. So you write 2.5. Delta T is nothing but change in temperature. Here it is written rise in temperature. How much? 15 degrees. So write here 15. Now solve this, you will get delta E equals to 56.25 kilojoule. Why kilo? Why kilo? Because the specific heat is in kilo. Okay, it is kilojoule. This much delta E. So first thing you have calculated delta E. Next, work done. How you will get work done? It is given that chamber is insulated. Chamber is insulated means heat transfer is 0. Means delta Q equals to 0. Okay. Now write down the first law of thermodynamics. What is the first law of thermodynamics? Delta Q equals to delta E plus W. On delta Q equals to 0, delta T you have already calculated. Put the values. You will get the unknown which is work done. How much heat is coming? Minus 56.25 kilojoule. Okay. So this is how you will solve a simple problem based on the first law of thermodynamics. You have to see the question carefully. What are the inputs given there? Note down. You should know what is the first law of thermodynamics. Write down it. Put the values. You will get the unknown parameters. So this is how you solve this problem. Now, next problem. A mass of 8 kg gas expands within container so that PV relationship is P into V to power 1.2 equals to constant. So this is a relationship. The process is going on in which there is 8 kg of mass is there and it is following this process P into V to power 1.2 constant. The initial pressure is given how much? 1000 kilopascal. Initial volume is how much? 1 meter cube. Final pressure 5 kilopascal. Next thing given is if specific internal energy decreases by 40 kilojoule per kg. Now what do you understand by specific internal energy? You know internal energy, unit of internal energy is joule or kilojoule. Specific internal energy means per unit mass. Per unit mass. That's why you can see unit is also kilojoule per kg. Per kg means kg is unit of mass. Okay. You have to find heat transfer. You have to find heat transfer. Magnitude and direction. Both things. Okay. Now, you know pressure. Initial and final. You know initial volume. So, you know initial pressure and initial volume. You know final pressure. You can calculate final volume. What is the relationship? These are some PVT relationships. In previous class I told you. So relationship between pressure and volume P2 by P1 equals to V1 by V2 power n. Or else you simplify it or rearrange. If you rearrange this you will get this thing. V2 equals to you need to find V2. V2 equals to V1 into V1 by P2 whole to power 1 by n. This is a relationship between pressure and volume for polytropic process. Now V1 is how much? 1 meter cube given here in the question. P1 1000. P2 how much? 5. And N how much? Here it is given 1.2. P into V power N equals to constant. In place of N it is 1.2. Okay, put down here you will get final one. It is coming how much? 82.7. Okay, now what is the formula for work done? Formula for work done is nothing but for polytropic process P1 V1 minus P2 V2 upon N minus 1. Now P1 is how much? 1000. P1 1. P2 5. V2 just now you calculated 82.7. N is how much given in the question? 1.2. Write down the values. You will get the work done. This much work done. Why kilo? Why kilo? Give the reason. Just write your answer in the comment box. Why kilo? Yes, because pressure is in kilopascal. Okay, so kilo is there. That kilo. That's why here it is written kilojoule. Okay. So this is the work done. Now, but you are asked to calculate heat transfer. You have to calculate heat transfer. This is the work transfer. What is the heat transfer in the case of polytropic process? You don't know? No issue. No issue. Why? You can apply first law also. But first law is nothing but Q equals to delta E equals W. We have calculated W. Now you have to find delta E. You have to find delta E. How you will get delta E? Here it is given specific internal energy 40 kilojoule per kg. Okay, this is specific and it is decreased. Decrease means negative. Negative. So minus 40 kilojoule per kg. Now you have to convert into internal energy. Kilojoule. See, unit of work done is kilojoule. Okay, so you have to convert this also kilojoule. How you will convert? This is specific internal energy means kilojoule per kg. So multiply this with mass. Multiply this with mass. So kg will cancel. You are left with kilojoule. Multiply this with mass. Okay, mass is how much? 8 kg. So here 8 into minus 40. So this much delta E. Put this value of delta E here and W also. Solve this, you will get Q equals to this much. This is your heat transfer and it is in positive direction. This is magnitude, this is positive direction. Okay. So this is how you have seen the second kind of problem. Now coming to third kind of problem. What is this? I hope till now I am clear. Here a gas is there which has gone through the thermodynamic cycle. It consists of some processes. What are those processes? Process 1 2. Given constant pressure. How much? 1.4 bar. V1. Initial volume is how much? How much is the initial volume? Just see here. Okay. So this is your initial volume. Now, initial volume is given 0.028 meter cube. Now, work done for this process is how much? 10.5 kilojoule. So, process 1 2, data is given to you, pressure is constant, that is 1.4 bar. Initial velocity is given 0.028 meter cube and work done is given, which is 10.5 kilojoule. Next, process 2 3. What is given for process 2 3? It is compression process, where process is PV equals to constant. Okay, and also it is given U3 equals to U2. Next, process 3 1. It is constant volume process, and also it is given difference of U1 and U3. U1 minus U3 is minus 26.4 kilojoule, and there is no significant change in kinetic energy and potential energy. Means neglect the kinetic energy and potential energy. Now, first thing you have to sketch the cycle. You have to sketch this cycle on the PV diagram. Why cycle? Process 1 to 2, 2 to 3, and again from 3 to 1. So initial is 1 and final is also 1. So it is one complete cycle. You have to sketch this on the pressure volume diagram. Next, calculate net work. You have to calculate net work. Then you have to calculate net heat transfer. Then you have to show total heat transfer equals to total work transfer. Okay. This is nothing but Gauss law for a cyclic process. So these things you have to do. How you will do first? You have to sketch the PV diagram. See, this is the PV diagram. How? First, constant pressure process 1 to 2. This is constant pressure process. Next, compression. Compression means what will happen? Pressure will increase and volume will decrease. Okay. So pressure is increasing. This is initial pressure. Pressure is increasing. But what about volume? Initial volume is here, it is decreasing. So this is PV equals to constant. Now it can come to here, it can go up also, it can come down. So how you will decide that it will come here only? Now see the third process. Third process is constant volume. Constant volume. Process 3 1 is constant volume means V3 should be equals to V1. V3 equals to V1. So draw this constant volume line. And where it will meet this graph, you will make it as 0.3. Okay. See, first make constant pressure process 1 2 from 2, because it is compression, pressure will increase, volume will decrease. See, from here either you can go downside also like this, or you can go up also. But why you have gone this side? Because you have to see that volume should decrease and pressure should increase. So this is only the case. Now you can go up to here, up above also, anywhere. So draw a graph. Now come to next process, process 3 1. It is constant volume. Means state 3 and state 1 volume will be same, constant. So from 1, draw a constant volume line, straight line. Where this will cross this curve, point this as point 3. So this is your graph, PV diagram. Now you have to find network. How you will find network? Network is nothing but sum of all the work. Means work done in process 1 2, work done in process 2 3, work done in process 3 1. Sum of all work will give you network. See, given here first process 1 2, work done is given 10.5 kilojoule. Now Work done is given 10.5. How? What will the formula for work done for first process? Constant process work done is given by P into delta V. Delta V is nothing but V2 minus V1. This is the formula. Now W12 is given to you. Pressure is given how much? 1.4 bar. So convert into kilopascal. Why? Because work done is in kilo. So convert this also into kilo. So 1.4 into 100. Next V2 minus V1. V1 is given how much? This much 1028. So from here you will get the value of V2. From here you will get the value of V2. Now next coming process 2-3. Work done for process 2-3 PdV. Okay, in place of P you can write P2 V2 by V. So this is the formula, or this can be the formula. Now why I have written V3 equals to V1? In place of V3 I have written V1. Why? Because here you can see constant volume means V3 equals to V1. Now in this equation, you know P2? Yes, you know. Why? Because process 1 2 is constant pressure process means P1 equals to P2. So P2 you know. What about V2? Here you have calculated V2. V1 given in the question 1028. Put all these values. You will find the work done for process 2-3. Okay? See carefully. Work done is given by this formula PdV. P can be written as P2 V2 by V. When you will simplify, you will get P2 V2 into log of V3 by V2. Okay. Now, because you know process 3-1 is constant volume process, which means volume at state 3 is equal to volume at state 1. So replace V3 with V1. Now put all the values. We will get work done equals to this. This is our work done in process 2-3. You know work done for process 1-2. Now you have to find work done for process 3-1. 3-1 is constant volume process. What is the work done in the case of constant volume process? Volume is constant, so delta V will be 0. Work done is 0. So W31 is 0. So what is the net work? Net work is nothing but sum of all these three work. W12 plus W23 plus W31. Add all this, you will get net work equals to this much. So you have calculated the B. Now you have to find heat transfer for process 1-2. To find the heat transfer for process 1-2. How to find it? Apply first law of thermodynamics. Come Q12 equals to how much? U2 minus U1 plus W12. Okay. Now W12 is given in question 10.5. Now U2 minus U1 how much? So for this we will do some small calculation. Given U2 equals to U3. Okay. Now also given U1 minus U3 equals to how much? Minus 26.4. U1 minus U3 equals to this much. Now U3 is equals to U2. To place U2 in place of U3, place U2 and simplify it. You will get U2 equals to U1 plus 26.4. Okay. So U2 minus U1 is also this much only. Understood? First given U2 equals to U3. Okay. Next given U1 minus U3 this. In place of U3 you can write U2. Okay, same thing we have done here. We have written U2 equals to U3, U1 minus U3 equals to minus 26.4. Take this side, you will get U1 equals to this much. In place of U3, put U3 equals to U2. Put U2. And so you will get U2 equals to U1 plus this much. So U2 minus U1, U2 minus U1 will be 26.4. Put it here. Put this value here. And work done is given already 10.5. Solve this, you will get Q12. Now similarly Q23, Q23, Q3 minus U2 plus W23. Okay. Now W23 is how much? This much. Okay. Now PV equals to constant. PV equals to constant, or you can say U3 is equals to U2. U3 equals to U2. So U3 minus U2 will be 0. And work done is how much? You have calculated minus 18 point this much. So put all this thing in the first law. For process 2-3 you will get Q23. Now Q31. Q31 constant volume process means work done is 0. So apply first law U1 minus U3 plus work done. Work done is 0. Now U1 minus U3 is how much? Already given minus 26.4. Put the value you will get Q31. Now add all these three. Add all these three. You will get total heat transfer. This is coming how much? Minus 8.283. Okay. So you have calculated this also. You want to also. Now you have to prove total heat transfer is equal to total work transfer. What is the total work transfer? Minus 8.283. And what is total heat transfer? Minus 8.283. Means same. Both are same. Total heat transfer is same as total work transfer. So this proves your Joule's law for cyclic process or first law of thermodynamics for cyclic process. It is heat transfer equals to work transfer. Okay. So like this, see in this question, graph was not given. You are supposed to draw the graph. So step by step go and draw it. Then process by process, go process by process. You will solve. You will get the unknown parameters. This is also a kind of by seeing question. You will can say that sir it is very difficult by seeing. But when you go step by step, process by process, it is very easy, very much easy. But the thing you should remember is for different kind of process, how you will find work transfer, how you will find heat transfer. That's it. And what is the first law of thermodynamics? And put the signs carefully. Okay. Thank you for today's session. I hope it is fruitful to you. We will meet you in the next session of thermodynamics. Till then, take care. Goodbye.